This is what packet you should have. You should have a note packet that looks like this. I want you to start off by putting your name up here. We're going to be talking about geometry and the essentials of geometry during this whole first chapter. Today we're going to take notes on section 1.1. When you see your notes look like this, you've got like a little number up here. What I want you to do is put the date, not the date, sorry, child. I want you to actually put the title and then the date beneath that. So you can go ahead and fill that in right now for yourself. So that should be identify points, lines, and planes. And you should have written that on the top line, and you can write whatever date it is that you're taking these notes. Okay, so with that in mind, here's what I want to do. I want to explain to you a little bit about your note packet so we can get started. So right here, you have a column that's kind of lightly grayed out. And what I want you to do is to only put vocabulary words here or important words, important terms, important phrases. I don't want you to put anything else in that spot. But then on the side next to that word, I want you to put the definition or drawing or something that's going to help you remember it. So what you're going to notice is that you've got 1, 2, 3 pages like that in this particular section before we get to the examples. So you're going to take the time to take notes like I'm taking. You have a bunch of vocabulary today, y'all. I'm just going to be honest with you. So let's go ahead and neatly write the vocabulary here. Write the definition, a drawing. It might be just a drawing sometimes. We're going to do that. So when we go back over our notes, we can clearly see the important terms, and then we can look to the left for our pertinent terms, and then to the right, we can see what they mean. Are you with me? So this is one way that we're going to keep our notes organized. So I think we've got about 11 terms that we're going to talk about today. So we need to get started. So I'm going to stop talking and we're just going to get into it. So the first term we're going to talk about today is undefined terms. Undefined terms refer to 3 specific terms in geometry. Those 3 terms are a point, a line, and a plane. So these are words that you probably are familiar with. Just mathematically speaking, it's really hard to define them. Right now, what you're looking at is a point. We usually use a capital letter to identify or name a point. So this would be point A. A point is undefined because really a point is a location. And so the fact that this dot that I drew has thickness, it means it's too big to actually be a specific point. If you can get that, I hope you do. But basically, I want you to think of a location, a very specific place. It has no thickness. It has no height or width. It's just a specific place. And so as soon as I draw a dot, that dot's too big because it's bigger than that one specific tiny pixel. Does that kind of make sense? I hope it does. A line is a little bit different. A line, back in the day, like we're used to talking about anything as a line, right? Like if I say, "Ooh, look at that, that's that curvy line." Mathematics, we don't do that. When we talk about a line, we are talking about a straight collection of points that are in a line, for lack of a better way of saying it, and it goes on in either direction forever and ever. So when you see a line in geometry, you're going to see an arrow. Oftentimes, the line is named by a lowercase letter. In this case, I'm using lowercase m, or sometimes we use 2 points on the line to name it. So this line is, let's say, line BC, or I could call it line M. That's 2 ways to name that line. Remember, these are called undefined terms because it's really hard to define it. A line has no thickness, right? And so the final undefined term is called a plane. So this plane, this is what I'm going to draw when I'm talking about a plane. A plane is a flat surface that extends in all directions forever and ever. If you think about a wall, like I'm looking at a wall right now, and you imagine that wall just extending up and out and over forever and ever, first of all, it wouldn't stay a rectangle shape. It would just kind of be stretching out. But we do use this shape. It's not a rectangle. It is called a parallelogram, and we use this shape to represent a plane. A flat surface with no thickness that extends forever in all directions in a flat fashion. Does that a little bit make sense? So that's a plane. And they're called undefined terms because honestly, they're really hard to define. When I refer to a plane, I'm generally going to refer to it as a capital letter. So I'm calling this plane R, or sometimes if we've got a number of points on the plane that are not in a straight line, let's call this X, Y, and Z. I could call this plane XYZ. So those are our undefined terms. And in a way, we just took care of 4 vocabulary words. So let's get started with a few more. So our next term is collinear points, and they really just describe points that are on the same line. So I'm going to draw a picture of that so you can see what I'm talking about. So suppose I have some line T, then on line T there's got to be some points. So let's put some points on it. So here are some points on line T. We've got J, K, L, and then we have M over here. What I want you to know is that J and K and L, those guys are a collinear. They're collinear because all three of them are the same line. But if I were to refer to J, K, L, and M, they are not collinear because there's not one line that would pass through all four of those points. Does that make sense? Write this picture down and write down the definition, please. So when we're referring to collinear points, remember they're points that are all on the same line. And so that's what you want to write down. And I think drawing a picture next to that would be mad helpful. And now we're going to move on to the next vocabulary word, y'all. So let's say you have a plane and you've got some points on it. Let's say B and C over here is on the plane and D is over here on the plane. This plane, by the way, is called R. And here's this line that's going through the plane, cutting straight through. And here's point F. The points B, C, and D are coplanar. F, not with the whole group of them. So B, C, D, and F, they are not coplanar because there's not a plane that goes through all four of them. Does that make sense? So coplanar means all of these things are on the same plane. In this case, all the points are on the same plane. Well, B, C, and D are coplanar. Write this definition down, please. So coplanar points are points that are on the same plane. More to come. Let's go ahead and move on to our next word. So our next, not term or word, but our phrase is going to be defined terms. Defined terms refers to any of the words that we're going to be talking about pretty much after the undefined terms we discussed. So notice that coplanar points and collinear points both have points in it. So those are defined terms. Why? Because we're using undefined terms. We're using the point, the line, and the plane to talk about other concepts. So defined terms are terms that are going to be defined using undefined terms. I know that sounds weird, but it's all going to make sense. So for our purposes, we'll say that defined terms are terms that can be described using point, line, plane, or any other known terms. And that's pretty much everything we're going to be discussing after this point in geometry. So our next term is line segment, and as you'll see, guys, I'm on the next page of my notes because I'm writing fairly large. You don't have to be, don't feel like you have to use up all the note pages, but I'm on to my second page, and my word is line segment. We remember what a line is. A line is a collection of points in a straight line that goes on in either direction forever and ever. What if I were talking about this part of the line from A to B? Just this little part right there. If I'm talking about that little part of the line, guess what that would be? A line segment. A line segment is a part of a line. It has a starting and a stop point. So in this case, this line segment would be called AB. I could call this line segment AB, or I can call this line segment BA. Either way, I'm talking about the same thing. Let me show you the notation I would use to represent that. All right, so let me say it like this. A line segment is a part of a line, and it's broken down with endpoints. It has endpoints, and that's going to be our next vocabulary word. So here's a line segment. This whole thing is considered the line segment, and a line segment has a beginning and an end. You can measure it, but it is not going on forever. A line segment is part of a line, all right? And sometimes, to be honest, we're not even going to use the word line segment. We're just going to use the part here. We're just going to call it a segment. And you should understand that it's a segment or a part of a line. So the endpoints are the beginning and ending of a line segment. How do we call a line segment a line segment? I'm going to show you. We refer to this line segment as line segment AB, and we put a little line like that on top of it with no arrows. Or we could call this line segment BA. So this is how the notation we would use. Write that down. And what this is saying, and I'll write down what it's called. This one's called line segment AB. This one's called line segment BA. And it refers to that. Both of those ways of saying it refers to that same picture. So once again, this is line segment AB or line segment BA. Sometimes we'll say segment. And a segment is part of a line, and it's broken off by endpoints. It's got two endpoints, a beginning and an end. It has a distinct length, whereas a line doesn't. A line goes on forever and ever. Couple more words, few more words, like 3 more, and we're done. So this next word is ray. So imagine if we started off with some lines like I just drew here. I'm going to go in and I'm going to just put a little endpoint here, and then I'm going to follow the line in one direction. What I've created is almost like half of a line. It's got like a start point. Let's call this, I don't know, T. So that's point T, and we use a capital letter for point. So I'll clarify that. So that's point T. So this ray starts at point T. I've created what we call a ray. A ray is like a half line. It has an endpoint, but then in one direction, it goes all the way in another direction, and it can go in either direction. Look, we've got another ray here that is going in this direction, and I don't know, let's call this point P. And so these are rays. Rays are a collection of points on a line that ends at an endpoint but goes in one direction on that line. So these are called rays. And I'm going to just do another ray right here. So here's a ray. It has an endpoint and then it goes in one direction. So here we are using that terminology again. That endpoint is coming back. So I'm going to highlight it with the endpoint color, but the whole thing is considered a ray. So let me go ahead and give ray her own color here. So we've got this orangey color. This whole thing is considered a ray, not the line part, but just the blue part there. So that's what a ray. So what's a ray? I'm going to write down the definition and I want you to copy it down too. So let's go over that definition again. It's a point on a line. This is what a ray is, right? And the collection of all the points on that line that's on one side of that endpoint. I know it sounds a little weird, but you get what I'm saying from our picture. We start at a point and then we go on one side of that point, continuing forever and ever in that one direction, and that's going to be a ray. And the next word that we're going to talk about is the phrase opposite rays, and it's probably exactly what you're thinking it is. So if I started off with a line like this and I had a point N and I considered 2 rays, right? So if I considered this ray here, let me make it a little bit, I'm going to highlight it for you so you can see it. If I consider this ray, let's say starting at N and going to the right, this is one ray, right? You're comfortable with that from our last definition. But then if I also consider, let's say, this ray right here, starting with this point and going to the left. I think I said right last time, or I meant to say right. So one going to the right and one going to the left. If I consider these two rays are called opposite rays. Opposite rays form a line. The only thing opposite rays have in common is that endpoint. I'm going to write a definition for you. I want you to copy it down. All right, so opposite rays, finally, are rays that have exactly one point in common. And another piece is that if we took all of their points that they have, they would all together form one straight line. So if we took all of these points and all of these points together, it makes one straight line. And guess what, guys? We've come to the end of our vocabulary. So let's go ahead and write this final word. So our final word is intersection, and what we see here is that we have an intersection. We've got 2 planes. I'm going to call one plane A. Notice I'm using the capital letter to refer to the plane, and I'll call this one plane B. Oftentimes in textbooks, it's not just a capital letter, it's also kind of a cursive-y fancy letter. So we're going to talk about plane A and plane B and the fact that they are intersecting where they meet in a line. The word intersection means the collection of points that 2 figures share in common. So the intersection of these 2 planes would be this line. I'm going to call it line L just because. So these 2 planes, A and B, intersect in in line L. Let me show you some other intersections. Hold on. So here's another intersection example. We've got ray BC. We're going to call this ray BC because it starts at endpoint B and goes off in the direction of C. Ray BC intersects line T at point S. And so remember, intersection is the point or points that 2 shapes have in common that are intersecting into one another. That's the intersection, and that's the end of our vocabulary. If you're like me, you've got a lot of space on another page. There's one final thing I want to talk about before we get into the examples. Make sure you have all the vocabulary terms. Just pause me, review, rewind, do whatever you need to do, and then we can do this one last thing before we get started with some examples. All right, go to your next page or get some clear space for me. I know this seems redundant, but it's not. We just want to make sure you have an understanding of these 5 key terms that we're going to be discussing. So I want you to understand how we're going to discuss it and how we're going to do it, like write it in shorthand. We're going to use some symbols. So if I'm talking about a point, you know, it looks like this. Generally, when we refer to a point, we're going to put a point and put the letter like this. So this would be called point A. We always use a capital letter when we refer to a point. So point A, that's it. There's no other way to refer to a point. But when we deal with a line, remember a line goes on forever and ever in either direction. We've got arrows at the end, okay? And so when we refer to a line, we've got a couple ways of doing it. So let me call this line line L. And usually we use a little lowercase cursive letter. In our textbook, they're not doing that. So I'm going to go with our textbook and use like a little slightly lowercase fancy N there. So I can call this line N, or I can talk about 2 points on the line and refer to it as line CD or line DC. So that's 3 ways for me to refer to this line. The symbol that we would use is, if I'm going to talk about it as CD, line CD, I'm going to write the letter CD and put a line over top it with the arrows on either side. Remember I said I could call it CD? I could also call it DC. So I can also do this. This is the symbol that I would use to refer to that line, or I could literally just write line N. So these are the 3 ways I can refer to that. And how would I say it? This would mean line CD. This is what I would say, line CD. I would call this one line DC. Write this down. I know it seems tedious, but it's going to help you later. And of course, that says line N, and that's exactly what it is, line N. All right. When we refer to a plane, it's kind of similar, except with the plane, remember, we've got this little picture. Do you remember what I called it? It's not a square. It's not a rectangle, but a parallelogram. If you got that, you can pat yourself on the back. Usually we have a large capital letter, usually in kind of script, that we would use, a little fanciness. But in our textbook, I'm not seeing it come up as much. So I'm just going to do a bold capital letter to refer to our plane. So one way to refer to our plane, I'm going to call this plane L. I'm going to use a bold capital L to refer to our plane. Another way I can refer to a plane is if I've got 3 points that are not collinear, that are not in a straight line, right? Those 3 points are going to define a plane. So I'm going to call these points, let's say E, F, G, E, F, G. So if I'm going to talk about this, remember the symbol that I would use, honestly, I'm going to write out the word plane in each of these cases. So I'm going to call this plane L or plane EFG. I can call it plane L, plane EFG. I can also move these letters around. I can call it plane FEG and change the order. So that's all acceptable as long as I'm talking about the 3 points that are not collinear, that are covering me and saying, okay, this is what a plane is. And that is exactly how I'd name it. So I'm just going to put an arrow there because the way it's written is the way it would be named. All right, so segment, when I have a segment, remember what a segment is, right? A segment has endpoints, and those endpoints, let's call these endpoints M and N. So this would be called segment MN or segment NM, all right? Segment NM, look at how I write it, NM with a line over top, no arrows. If I had arrows, I'm referring to a line. No arrows mean I'm referring to the name of a segment. And so this segment is called segment MN. I can refer to both of these segments in exactly the same way. And so this says segment MN. Thank you guys for being patient with me. I know this is tedious. Write it down. This is segment MN. NM, my bad. And then this is also referring to segment MN. And that's what we would say when we see it. All right. Finally, this is straightforward, but it's important for you to get it. So make sure you pay attention to this last one. So let's call this point D, and let's say this is C. The only way to refer to this ray is to call it ray DC. That's the only way. And when I call it ray DC, notice the endpoint has to be written first and I put an arrow in the direction of the next point that is after the end point. So segment DC, ray DC, sorry about that, is how I draw that, and ray DC is how I'd say. All right, so with that, there's only one way to talk about a ray, and that's from its endpoint into the other direction. CD would not do, but ray DC is the way we do this. With that in mind, the next time we have a video together, it's going to be going over these examples. So make sure your definitions and your symbols and labels are all tight and you understand it, because we'll talk about it in class today. Look forward to seeing you guys as soon as possible. Take care, and I'll see you soon. Take care. Bye-bye.